This demonstration is to show you that we are surrounded by air pressure that we never really think about, but it's certainly all around us all the time. What I have is a soda can. In a soda can I've put about this much water in the bottom. So I'm heating the soda can. What will happen to the water? Well, we're hoping it's going to come to a boil. Now, we're all familiar with boiling water. We don't always know what's going on when something boils, though, because we don't think about that. So just briefly, think about water molecules inside a can, and they're close to each other, and they're bumping into each other. As I heat them, we know that they're going to begin to move faster. As they move faster, they push on each other with more and more force. And so when the water molecules push on each other with the same amount of pressure, if you will, so you get a pressure built up inside, a force per unit area built up inside the water, and the atmosphere is pushing on the surface of the water. And when the molecules push each other, as hard as the atmosphere is pushing on the surface, the molecules form little pockets of water vapor, and then they make little bubbles and get out of the liquid. And so we're going to see that begin to happen here. As the water molecules move from the liquid into the vapor phase, which we commonly call steam, we're going to see the steam start to come out of the can. I don't know if you'll be able to see that on the camera or not, but in a minute you all know that when something boils, there you go, saw a little proof of it. There's another one. When it begins to boil, the water vapor is going to come out. Of course, if the water vapor comes out, the air is also coming out, so air is escaping the can. What I'm going to do is use these tongs to flip the can upside down in this cold water. When I do that, the cold water is going to cause the steam, well, you know what it's going to do. What's it going to cause the steam to do? It'll go back to the liquid phase. So it's going to go from gas, which it's in right now, back into liquid. When it goes into liquid, now the can is empty, and normally air would come in to replace it, but I'm going to have it upside down in this cold water, so air will not be able to get back in. So really what I'm going to create by turning it upside down into the cold water is an empty can. When the can is totally empty, the only force that is on the can is the force exerted by the weight of the atmosphere on the can. Let's see what happens. And so you can see that when I seal the can and air can't get back in, the atmospheric pressure, the force exerted over the surface area of the can, is great enough that it just causes the can to smash. Now, the atmosphere exerts a pressure of about 14.7 pounds over every square inch of surface. 14.7 psi. So think about your body for a minute. How many little square inches do you have on your body? There are lots of them. And each square inch would have a pressure exerted on it of 14.7 pounds per square inch. That's why the can smashes when it's empty, because there's nothing inside to push out, and the atmosphere just smashes it. So this kind of pressure is around us all the time. We just never think about it. So once again, when I talk about pressure, it is force divided by square inches. And I'll do a little video with paper and pencil which shows you how we measure force. But I'm going to do that at my house. I just came into school to do these demos. All right, so the can smashed because the atmospheric pressure pushed it together when there wasn't anything inside the can to push the inside back out.